and welcome back to Pass the Torque. I'm your host, Katie Kadri. This week we have Jeramie Broadway with us, based out of Marshall Space Flight Center. He's here to tell you about the M in OSAM. In past episodes, we've learned about on-orbit servicing and assembly, and today we're here to learn about manufacturing. Without further ado, I'll pass it to Jeramie. Can you tell us about your background and what you do now?
So good afternoon, everybody. I'm Jeramie Broadway. I'm at NASA Marshall Space Flight Center in Huntsville, Alabama. I've been with NASA Marshall for about 12 years. I came from Marshall, started my working career. I was in the military. I was in the Air Force for 6 years and stationed in North Dakota and got my mechanical engineering degree while I was up there. And that's when I made my way down to Huntsville, Alabama. I've been in the materials and processes structures area for pretty much that whole time over the 12 years. I worked in the materials and processes lab doing production for the Constellation program for that rocket. And whenever that went away, I transitioned to the new SLS program, working production for that rocket. And now for the last few years, I've been in the Partnerships and Formulation Office, which is basically the business development office for NASA Marshall. I go out and look for new technologies, look for partners. How can we grow these technologies for the center, to help grow the center, help meet the agency mission, and then obviously help grow that technology with our industry and academic partners. So that is where I'm at today.
What is in-space manufacturing, and how does it compare to manufacturing on Earth?
So we try and explain this in two different ways: for space manufacturing and in-space manufacturing. So for space is launch vehicle manufacturing, structures, habitats, anything that we would make on the ground. Even though it may be used in space, it's for space. Versus in-space manufacturing, we consider the gamut of all the additive manufacturing that we're doing on International Space Station today, as well as our OSAM things, our on-orbit manufacturing, which is outside the pressurized volume, and then as well as planetary surface manufacturing. So our sustained Artemis Phase 2 activities, that's manufacturing on the lunar surface. So for space manufacturing, again, is terrestrial type applications, and then in-space manufacturing is everything off the surface of the Earth. There's tons of development going on for in-situ resource utilization, or ISRU, for manufacturing. Not even for manufacturing, just consumables. When we think about being on on the moon's surface, we can't take everything that we want to manufacture and use, and we can't bring that to the surface with us. So we need to figure out how to recycle structures that we place on the surface. If we're not using those anymore, how do we chip those up and turn that into usable materials? How do we take the ISR or the regolith and separate the constituents and use it for manufacturing feedstocks? How do we use it for rocket fuel to refuel our human lander system? And then on orbit activities, obviously on a free flying platform like space station, we want to minimize the mass that's up there. So again, we need to figure out how to recycle packaging. How do we recycle spent components that may have broken or malfunctioned? How do we either fix those or recycle them or reuse them in another manner? So ISRU, once you get off the Earth's surface, is huge to sustainability, especially as we start thinking about going to Mars and those longer deep space transportation missions. We certainly can't take everything with us, and we need to reuse, recycle as much as possible.
Has in-space manufacturing been done before? What will it look like in the future?
So in-space manufacturing, the largest project to date is NASA Marshall's in-space manufacturing project. That's the name of it. The focus of that project is in International Space Station 3D printing. That project fully kicked off and began in the 2017 timeframe, or 2014 timeframe, excuse me. The very first 3D printer was flown in 2009 to get zero-G data. And then from there, it transitioned in the 2014 timeframe to the in-space manufacturing project, which is flying on station now, with our industry partners to be able to print plastics, to print tools, working on recycling, again, those packaging materials that go up to station. So to date, that's the longest running in-space manufacturing project. And then we have the OSAM 1 and OSAM 2 missions, which are outside of a pressurized structure. They're free-flying missions to be able to manufacture on orbit. So those three activities are really the main in-space manufacturing type activities that have been going on.
How does 3D printing work in a zero-gravity environment?
So gravity is a huge deal in space. You're correct. There's numerous processes, but for space manufacturing, additive manufacturing is that layer by layer buildup. And it's the same thing for on orbit. It's just different. It's more of a feed process as opposed to a powder. So if you think about one of the main manufacturing or additive manufacturing processes is a laser powder bed fusion. And so what that means is there's a bed of very small particles of metals, and that laser comes and melts each layer in the specific design. And so we can't do a laser powder bed on orbit because all those particles would just float around inside the build chamber. And so for the space station activity, it's a kind of a plastic wire that feeds through and melts it and places it where it needs to be, but it's still a layer by layer process. And so even when we think about OSAM and the non-pressurized structured manufacturing, it's going to be more of that wire-fed type activity where we can work with the effects of gravity and not have them work against us.
Why is in-space manufacturing important? What are its benefits, and what are some future applications?
So in-space manufacturing, we talked about the four applications as far as inside pressurized structures, space station, gateway, whenever we go to Mars, free flyers to be able to manufacture new materials and hardware, as well as on the lunar surface. And when you think about there's nothing on Earth that we don't manufacture. There's some sort of material process, there's some sort of manufacturing process, and that's just how we create products, that's how we repair products. And for us to truly be sustainable on the surface of the moon or as we transition to Mars, we're going to have to manufacture new products. We're going to have to repair products as things break down, because they always do. And so being able to have multiple processes that we developed, for astronauts to do, but also autonomous operations is going to be imperative for sustainability. And the second part of that is not even just, it goes back to that take it or make it, don't take it, right? Is we only have so much mass that we can lift up on orbit. And so if we can, again, back to the ISRU and the feedstocks, if we can recycle and create the materials that we need, the feedstocks that we need, and make things on orbit, those structures become larger. Our use cases, our applications for on-orbit activities and lunar surface activities just grow. And so without the continued development of in-space manufacturing, it's going to be very difficult to get to where we want to be from a lunar outpost or a Martian surface outpost. Things to achieve that, we've got to be able to have in-space manufacturing. I'm sure you have seen the pictures of from space station, the socket wrenches and the wrenches that they're making, small replacement parts. There's an activity where they're looking across space station and what are the types of components that break, what are those designs, are those replacement parts that we can 3D print. And so that's certainly one application. But we'll continue to use space station as a development platform for new materials and new processes. But again, those replacement parts are not large-scale additive, which is where we want to be. When you think about OSAM, unpressurized structure manufacturing, if we want to manufacture large aperture telescopes that we can't, if it's too large to launch inside of a launch vehicle fairing, let's manufacture and assemble it on orbit. And then if we're doing that on orbit, that allows us to manufacture larger and larger aperture telescopes creating greater exploration, greater science. And then from a sustainable standpoint on the lunar surface, if the habitats and rovers, if we're there for 7-8 years, those things are going to break. And so if we need to repair the rover frame, that's going to have to be done with larger scale, either additive or welding processes or and subtractive processes. So we've been talking a lot about additive, but it's really all manufacturing processes, welding and brazing, machining type activities to remove metals. So there's definitely, as we scale, and then there's also the portion of transitioning from manufacturing to construction, right? So we're building houses here on Earth. The goal is to use ISRU and lunar surface construction to build homes and habitats and roads and radiation shielding type structures. So it's certainly not just a wrench size activity. It's wrenches and tools, but all the way up to rover frames and habitat structures as well.
Can you describe the M part of the OSAM-1 mission?
So OSAM-1, as we've said, on-orbit servicing, assembly, and manufacturing. That M is the manufacturing part, and it's part of the Spider payload. We mentioned it earlier. It's a composite boom manufacturing process that'll, I believe, a 10 to 20 meter boom, which when we talked about earlier, large aperture structures or large truss structures to be able to create, manufacture large structures. We can only deploy solar arrays that are so big now, but if we could build these trusses as large as we need them to, as large as we want to, and there's also manufacturing processes where we can come in and print the electronics and truly create a whole new solar array. That is enabled by the OSAM-1, by the boom extension and MakerSat, all of these things to demonstrate these first order technologies on orbit, to see how the materials behave, see how the processes behave. We can only do so much on the ground. We think we understand it, but this will actually, OSAM-1 will go up and demonstrate that composite boom manufacturing process, and then we'll be able to tailor that from lessons learned on the next mission and future missions.
How are different NASA centers collaborating on manufacturing? What role do companies play?
So manufacturing as a whole, and I mentioned it earlier, you can't do much without having materials and manufacturing as a part of it. And so from an agency perspective, most centers are involved in some level of manufacturing. But from an OSAM perspective, NASA Marshall is focused on the manufacturing portions, NASA Langley on the assembly, and then Goddard for the servicing. But all three of those are connected and cross-cutting. All of the the technologies for those three different areas are overlapping. The servicing aspects, right, for OSAM-1, the grappling and the robotic arms and manipulating things, those are all the technologies that we need to go demonstrate being able to join two materials in a welding process. I need two robotic arms to hold that material. And so those three centers are really focused on the OSAM portion of manufacturing. But for space manufacturing, again, we have partners all over the agency doing certain aspects of it. From a commercial standpoint, all of the small launchers that are out there right now, 3D printing tank structures, 3D printing engines. I mean, our ability to reduce costs and schedule by manufacturing technologies is really what's the benefit of additive and driving down costs and allowing so many small launchers to be on the market and allowing all these small launchers to take more payload up to orbit.
What has been your favorite accomplishment from your time at NASA?
So my favorite accomplishment, I worked on Exploration Mission 1, the multi-purpose stage adapter. I was the production manager for that build, and what that is it's on the SLS rocket, and it connects the Orion capsule on top to the rest of the vehicle below. And so I was the production manager for that. That will be, whenever that launches, that will be my first piece of flight hardware. So I'm most excited about seeing Artemis 1 launch and knowing that the team at Marshall and Langley that help produce that piece of hardware, that it's going to fly and it's on the first flight. And so that's one of my favorite pieces so far.
What NASA mission or moment are you most looking forward to?
So I mentioned the EM1 launch because of the hardware. I think it's very exciting to be able to, when Shuttle retired, I was just coming into to NASA, so I didn't work too much on Shuttle, but have put a lot of time into SLS. So I'm very excited for EM1 and this next generation of rocket and mission. And then certainly in 2024, Boots on the Moon is going to be an exciting event for the country and for NASA. You know, it's an exciting time, and America, the world really, looks to space for inspiration, and Boots on the Moon in 24 is going to be a great event. And then technology-wise, you know, being sustainable on the lunar surface, I'm excited that hopefully I'm still involved in NASA and the technologies and the things that are going on, and whenever we become sustainable on the lunar surface. So it's exciting times in NASA now, for the agency and for the country, and I'm excited to see it.
What do you do for fun outside of NASA?
So when we're not teleworking, we're a water family. So we like to be out on the water as much as possible, hanging out, relaxing, tubing, wakeboarding, as much time out on the water as we can. That's what we do for fun around here.
Thanks so much, Jeramie. And thank you for tuning in to another episode of Pass the Torque. Don't forget, you can drop a question for Jeramie in the comments below for a chance to have them answered later this week. Don't forget to tune in next week for another brand new episode of Pass the Torque. See you then.
Hey everyone, a little bit of behind the scenes. I enjoy playing ping pong. We've got a ping pong table down in the basement. Play with the kids whenever we can. It's another thing I like to do to have fun, pass the time, play a little guitar. One of my favorite songs, I call it my moon song, because if you could only take one song to the moon with you and that's the only song you heard for the rest of your life, what would it be? So mine is Pink Floyd, Wish You Were Here. Certainly not singing for America, but that's just a little taste.